everyone, and welcome to today's Python Exchange. My name is Cameron Riddell, and I will serve as your host this afternoon. Today, we are joined by a very special guest, Dawn Wages, who is going to share with us her thoughts on AI. However, before I introduce Dawn, we are also joined by our usual crew of host panelists. So let's take a moment to get to know each of our host panelists before we proceed. James Powell is here joining us. And so, James, can you remind us, for our audience members who might be new, what it is that you do and what it is that you consider yourself maybe an expert in?
Hi, everybody. My name is James Powell. I work together with Cameron. We deliver a lot of training to scientific users, such as those at labs like Brookhaven. One thing that I've been thinking about recently that I'd love if somebody or curious enough to ask me about is for scientific workloads like those at DSSI or similar facilities, when are deployment tools like Kubernetes too much? If we need to use them, how do we use them effectively without having to learn a lot of stuff? Or if we choose not to use them, what alternatives are available?
Fantastic. Well, James, it's always a pleasure having you join us because your technical background goes infinitely deep, and so your perspective is always appreciated. We're also joined by Kari Berry. So, Kari, same question to you. What is it that you do, and what is it that you maybe consider yourself an expert in or just really good at?
Right. Well, let's see. I think a core aspect of this job that's come to light lately is the need to reformat and deal with JSONified data and the million and one ways to do that, the million and one ways different APIs accept that, and how portable that is in terms of its ability to go into Redis cache, its ability to move all these different places, serialization and deserialization. So I would consider myself really good, if not an expert at that. I know that I was hired to be a Kubernetes person, but still getting kicking the tires with some of the tasks required to set that up, kind of like James was saying. The phrase we used to say at my previous job where I ran the cluster was like killing a cockroach with an atomic bomb. And sure, that's certainly a good analogy, but it definitely can be useful in keeping a service alive and stable. So looking forward to doing that too.
Absolutely. Thank you so much, Kari, for joining us today. Last but certainly not least, for our host panelists, we are also joined by Tom Caswell. Tom, can you remind us what it is that you do and what you consider yourself to be really good at?
I'm Tom Kessel. I'm at Brookhaven National Lab at NSLS2. With my other hats, I'm the project lead for Matplotlib. I guess I've experienced maintaining large, widely used libraries and visualizations. So I'm happy to take discussions of either of those. I've recently I finally got on the try AI for coding uh, hype train, and it does sometimes feel like killing a cockroach with a nuclear weapon.
Excellent. And Tom, do they have is there an Emacs plugin for that?
Uh, there is, but I've not set it up. I've been my workflow is I use one tool for driving the AI, and then
Mhm.
I review all the code and commit it in Emacs. So I
Ah,
have a clear separation between when the robot's working and when I'm working.
yeah, very fair. Well, Tom, likewise with both James and Kari, it's always a pleasure having you join us because I love your expertise in a lot of these topics. Now, let's formally introduce the guest of the hour. Today's session is about taking control of your AI stack, and we've got the perfect guide to help us do it. Don Wages is the Community Director of Developer Relations at Anaconda, the company behind one of the most widely used Python distributions in AI and machine learning. Don's also a software engineer and a former chair of the Python Software Foundation and a leading voice in ethical, sustainable open source. Given her extensive background in this area, I'm very excited to have Dawn with us today. So please join me in welcoming our guest, Dawn Wages.
Hey everyone, it's an honor to be here. Thanks so much. My name's Dawn Wages, she, her pronouns, and I'm calling in from Philadelphia. And yes, Cameron, thanks so much for introducing the topic of the hour. So when we talk into this, the way that I've approached this conversation, and really, I love the highlight question that Cameron started with is what you're an expert on, or how do you consider yourself your expertise? This has been a vector that I've been having a lot of conversations with in the open source ecosystem for the past year. My background is in developer relations and developer tools, specifically in Python, but across the ecosystem. I really dig deep on developer tools, what's a valuable user experience, and how developer tools fit in your stack. So one of the styles of presentations that I typically like to approach is taking an end-to-end process or a full stack, and then doing this 100,000 foot, 40,000 foot view on what tools people are using and why, to give this kind of competitive mental model for people. So as we proceed, and if there are questions in the chat, or as we continue, or we find people with more expertise in a particular area, I really hope this continues to be a discussion. So the goal is to empower people to build their own castle, to dig their own moat, and it allows for this concept of AI sovereignty, provenance, and compliance that we'll get into more today. I'm citing a number of sources today, and if you are interested in approaching these sources, use that link on the bottom right-hand corner. I think that QR code might be a little bit out of date, but that bottom right-hand link will take you to the slide, and you can see the sources yourself. Again, my name's Dawn Wages. Thanks so much for joining, and the things that I really focus on lately have been around collaboration and mentorship. I am a trekker, so really my goal is for tech optimism, but not in this kind of delusional or devoid of reality approach. I think it's really important to build the world that you want to see, and also recognize that there is not a utopia on the other side of the tools. We will continue to see, specifically in AI, serves as a force multiplier for existing systems. And so we need thoughtful and concerted efforts to be able to build that future with technology. And I also consider myself a super connector. So you may see me around the conference space pretty regularly. And if you do, I love to connect people and partnerships to solve problems. So what we're covering today, we're going to start with AI sovereignty, defining what sovereignty is, and then kind of doing a little bit of a poking on what language you're using as we're describing sovereignty. I like to lean into autonomy, just to kind of not bury the lead. And then I'll talk a little bit about the threat model that we are facing with a particular lens on government context, because I did know who I was talking to today, so I added an extra lens there. And then the rest of the presentation, most of it is going to be really digging into some of these core concepts and applying them. And then self-hosted, that's a really interesting slide that's been a culmination of a lot of conversations, and then some getting started practices. AI sovereignty. So, what does that mean? There are many emergent conversations in the ecosystem really defining what sovereign AI is, but I describe it as a continuum rather than this binary condition. Do you have sovereign tech? Is more of there's a deluge of choices you can make as you're building your full stack. And we're balancing out that autonomy with our interdependence on code and these complex systems. So rather than thinking of a single checkbox, it is a list of checkboxes or more of a spectrum. But with AI sovereignty, you're able to put forward more control of your stack, have more visibility into your full stack, uh, ensure, hopefully, reproducibility of that stack, and then really limit that data egress that you are putting into your AI system to be able to continue that sovereign take. And I like to describe this more as autonomy, as I mentioned. Other common language patterns that people are showing are data lineage or your model lineage. Sovereignty, the reason why I'm retiring it specifically, but it's a little bit of a gotcha with the title of the presentation, but it's been more increasingly a part of these national AI policies and strategies. At the same time, sovereign is invoked as this commodification language. So companies now sell sovereign AI factories, clouds, language models to governments and enterprises and various communities that are concerned with security. But it allows for this kind of interjection of moving away from really where that point may be, right? It has this political layer over top of it. And so I really enjoy using autonomy. It's a much more accessible, um, oh, and also a better, easier to spell because I missed a letter. Easier to spell description of what we're trying to get to today. So you may be familiar with this experimentation loop. This is comes constantly if you're building complex software systems or if you're doing research approaches, but you're going to plan, design, build, test, and then release for the public. But for people who are knee deep in building experimentation in different systems, they'll know that it's not typically as laid out and easily formatted as the previous slide. You may have a planning phase, and you may want to turn that plan upside down on its head. You may want to design, some stick, some don't. You may use prompts and to help with your design process, and that may change the way that you build or test. And then your experimentation cadence or your product release phase may look drastically different between by the time you have your single or many false starts and stops. And in that, as we were building, we are addressing the layers of the AI stack, right? So this is really sharing the fundamentals of what that stack is going to look like, and we're going to be referencing this particular stack iteratively through the next several slides. But that threat model you'll see can come from your supply chain poisoning, your data poisoning, model poisoning, or patterns that are attack vectors for your agentic systems. So some of which could end up being like malicious model weights. You can also have like poison packages, depending on what your package index is, training data manipulation. Excuse me. You can also backboard a base model, for example, or data exfiltration, as I mentioned, data leakage in your workflow. Also, eval manipulation and prompt leakage as well, I consider as data leakage. And so that nation state kind of government context that I wanted to put a lens over top as specifically for this audience. A lot of the literature, and specifically the literature that I'm referencing at the bottom of the slide, the goal on sovereignty is where your research is taking place. Where is that compute physically and what that location is? But my talk is more about what the controls on the stack are. These are different questions, or can be the same question, but on different scales and with different answers. So, for whether or not a data center is in the right country, but if you don't own the runtime or the model layer or the evaluation criteria, the location of the stack is much less important without that sovereign or autonomous component. So you'll have a different failure model based on reframing the question to be more autonomous. So starting out with that data layer, some common practices, or excuse me, emergent practices that are really cool in the ecosystem. Git is a common tool in the ecosystem, and it has been for the last maybe 20 or so years. But applying that to versioning for data sets and models, which works with local or self-hosted object storage. You could also use data storage like Delta Lake, Apache Iceberg, and Apache Hudi, which offer data lineage for your data lake. And those apply to a pipeline use cases as well. All are open formats, and you'll see a theme through this presentation that having open code also allows for sovereignty because you are able to have that clarity I mentioned, and you can inspect without vendor lock-in, for example. Data provenance, or excuse me, the Data Provenance Initiative is a really cool organization. Recently, they audited about 1,800 data sets that were fine-tuned. And what they found were widespread violations in that large corpus. And it be enabled their ability to be able to do that. And they opened that source up. And so you are able to look at that compilation of all of the lineage, or excuse me, all of the auditing that they did to be able to understand a little bit more about some of the threat vectors that I mentioned before. So, like the specifically in your data layer, the lineage includes the open original source, whether or not there's associated licenses, or who the creators were involved with collating that data source. You also, another really interesting tool that the ecosystem's kind of converging around are data provenance cards. You may be familiar if been working with data for a long time, are data sheets. This would be considered an upgrade. Excuse me. um, where cards are able to now link to repositories, copies or aggregator copies, and then any of the papers or creators those were linked to. You're also able to have text to machine searchable sources and those licenses, as well as like languages, tasks, and format and metrics, text metrics associated with that data set, which is really cool. So I mentioned the Data Provenance Initiative. There's also one that's been really on my radar lately is C2PA, which is the Coalition for Content Provenance and Authenticity. And so that one's really interesting. That organization is really interesting because they're approaching their data from data provenance from a different lens, same language, same word, but different approach. So C2PA has been providing machine readable provenance standards, which is awesome because if you're looking for things to be more autonomous and without human intervention, or to programmatically insert human intervention and have it autonomous in between states, having machine readable standards is really cool. And so C2PA is answering the question of what happened to this artifact, this data artifact, and then can it be verified cryptographically? But then the Data Provenance Initiative is interesting because they'll check to see, or they're checking to see what data set exists, what are the licenses, and is the metadata accurate specifically. For the model layer, model cards have been around for the last several years, which are designed to provide transparency, but the ecosystem is finding that they're falling short on some of the traceability and genealogy of the models. So there are projects that are coming forth that are really excited about enabling machine readability, just like we mentioned in the data layer, offering reliable centralized management, and then also making sure that the audibility starts earlier in the stage of maturity than rather than looking at it at the maybe at the end when you're really thinking about your software supply chain security. SigStore specifically is also a really interesting tool that is under the OpenSSF that allows for model transparency projects, and it has verifiable claims about model integrity and provenance as well. So users are able to come in like with all of these tools and check for themselves what these claims are true rather than having to trust a model trainer. Another one is model weights and their licensing. And then SUSE is an interesting organization. It's a company, but they built this rating system of 0 to 4 based off of the EU sovereignty objectives, where you can have from no sovereignty to full digital sovereignty. And it was important for me to add this to the list because this is kind of a thoughtful and simplified framework that a lot of people are using these days if you're specifically using SUSE as a vendor. So like it has some of the objectives weighted with different attributes over 8 objectives. So you're looking at your supply chain, your strategy, operational autonomy, that technology, that literal stack. It also includes your legal and jurisdiction, as well as your data, security compliance, and your environment. So that really kind of maps almost one to one with that layer, the layered stacks that I have on the screen. OpenSSF, as I mentioned, is a organization to watch. I really enjoy their content, and they also just recently in December published an AI educational training module that I absolutely recommend people take, especially if you are getting started or you're interested in, yes, there's this big AI world, but how do I do so safely? And if you're interested in being on the bleeding edge or a stakeholder in the future of enjoy or engaging with AI on a safe and secure or autonomous way. Um, so I mentioned Sigstore already. These are open SIGs model signing that lead to model transparency. There's also this model signing spec. We are currently at version 1.0 at the time of this recording. And that integrates a number of things. So they have a working group that they form a working group model. If you're not familiar with Linux Foundation, there's sub foundations and the way that they interact or get things done under those organizations. They use a working group, and that group is actively building towards creating these embeddable, machine readable model card information. NVIDIA, OpenSSF, Google, and Kaggle are among the short list of organizations who are investing in this process with OpenSSF. They're interested in end-to-end model provenance and attestation. I'll talk a little bit more about it in a future slide, but it's building on the Atlas framework. And then specifically NVIDIA and others, but specifically NVIDIA is interested in GPU accelerated model integrity verification. Um, on the screen also, I have Aspen Digital, which is really cool. It is an arm of the Aspen Institute, and it's more of a community and public interest. So they're working on creating community-aligned AI benchmarks for their projects. It's called the AI Aligned AI Benchmarks Project. And so that is a work stream that they're using to talk with communities and define goals for future AI research. So through that full model process, and this is, I borrowed this process um, diagram from a number of other presentations I give, and I think it summarizes things, but also it's not exhaustive. But through specifically the model process, there have been people are experimenting with using traditional CI/CD tools to be an automation engine for verification in each step of that, specifically the model process. GitHub Actions has been the de facto automation engine more recently, but also any CI/CD tool can integrate with some of these open standards to evaluate your model process. So starting with data set pre-processing, you can schedule with your GitHub Actions or your CI/CD. You can also have your training and evaluation be integrated into that automation engine, your deployment and your inference. And then throughout that end-to-end process, artifact registration is this receipt system for your entire pipeline. So every time a significant artifact is produced, or you transform an artifact if you want to be very thoughtful about your provenance, you will get a receipt or a signed verifiable record of where it is, what it is, where it came from, and what went into that delta, that change. So tokens and embeddings are these specifically are these intermediate representations, and they don't show up as where I'm drawing some of our arrows. Um, Unless you're storing your embeddings as a reusable asset, like if you have a vector database included into your stack, um, then embeddings definitely would be part of that corpus that would need registration if you're including it. But specifically, I didn't mention it unless you are using that as this kind of intermediate representation and you're going to continue to reuse it. But it does show up after training, after fine tuning, or excuse me, artifacts do show up after your training, after your fine tuning, during your data stage, and during that inference stage. And then, yes, as I mentioned, embeddings specifically, if it's a reusable asset, you'll typically find that, or it's great practice to include these. So going deeper down to this stack, um, OLLAMA and Llama CPP are the are industry standard these days. These are one command polls and they run model locally. So they handle things like quantization and expose these compatible APIs without configuration. VLLM specifically is engineered for high throughput. So if you're working with large systems, um, awesome, great. If VLLM is, if you're working with large systems, it's authored and built by Red Hat. And so that's a really great open source repository of quantized, that works well with an open source repository of quantized models for VLLM. I also recommend, especially on large scale systems. And so these are really coming from, and as I continue to go through this and I'm like kind of rattling off things that the ecosystem is talking about, it's because I'm hanging out in the hallway track of a lot of different conferences. And so I keep trying to create these mental models on how people that I'm discussing at enterprises or people who are exploring individually and are just curious about how to approach these. I'm creating mental models on how to create this checklist. And so as I see some movement in the chat, which is really, really exciting. So I'm excited for future conversations on how this shows up in your system. So these are more large scales. If you're considering tools that are open source for auditing, if you start locally, which I'll get into some more practical approaches later in the presentation, but if you start locally, the model format GGUF is the universal format for bundling weights, tokenizers, and metadata. So if it's running locally, you most certainly are going to be supporting GGUF, but that's good for the sovereign approach because it means it's going to be portable between your different runtimes as you are in your development, your production, or your staging and your production workflows. I also recommend being thoughtful about your gateway architecture. I'll talk about this again. It's really interesting how a lot of these concepts are cross multiple parts, layers of your AI stack. But gateway architecture specifically will allow for centralized control and routing and observability, definitely borrowing some of the approaches from traditional software architecture. You're applying that same lens to your AI infrastructure as well. And so that will give this single choke point for your logging or your access control or the PII, your personally identifiable information, and have that as an area where as a checkpoint for scrubbing that. And then your environment layer, this is one that Anaconda plays in heavily. So I do developer relations for Anaconda. Before this, I worked at Microsoft for VS Code, supporting the Python developers there. And Python runtime is really my favorite part of the stack. And I can talk for days on it. So if you have thoughts or you want to talk more about Python runtime, I would be tickled. But so I have a smattering of logos on the screen. I'm really excited what's going to come out from Zarf, the air gapped tooling that's under the OpenSSF as well. But I recommend Conda Lock or Pixie Lock. Those pin your dependencies to a particular hash, which is secure. You want to know, and then that hash will change. It's a long number. That hash will change if there are changes to your environment. So I like that's a really great auditable tool that you can use in your ecosystem. Also, using trusted channels. Channels is the language that we use on anaconda.org because it is the author of this distribution. You can have multiple authors for a particular channel. But I would recommend using defaults that are trusted or verified mirrors, excuse me, and not just random packages you get off the from the ecosystem. And I also want to let you know, like, it's even if they're trusted channels, right? Like, security is a process, not necessarily a singular product. So even through that, there are new threat vectors that are happening every day. I mean, people are maybe familiar with the light LLM attack that happened through a tool that is specifically designed to improve the security of our infrastructure. We're finding some interesting or alarming ways that people are able to get tokens or access keys, not just put in through your commit, but like through other ways, and then using that as a automated and widespread attack. So just being thoughtful that all of the contributions that you add to your AI stack will continue to make your workflow more secure. I mentioned reproducible builds. That means someone else can create your stack from your lock file. And then I also mentioned air gaps or mirrors, which means that there is with your physical hardware, depending on what hardware you're using, that others are not able to enter without having secure, verifiable mechanisms. The evaluation layer is one that I think is the most discussed right now, specifically with model evaluations. Eleuther's AI is the standard benchmarks. It has like 60 plus benchmarks that are underlies the Hugging Face OpenLLM leaderboard. So you may be most familiar with that if you're interacting with Hugging Face. You can run it locally, which is also attributing to that sovereign narrative. Um, Deep Eval is another open source LLM evaluation framework. Again, you can run that locally. It answers on hallucinations, relevancy, faithfulness, all the contextual recall, and you can do that locally on your machine. There is a pattern that people are using. I would be really open to feedback on whether or not people like this pattern or it sounds interesting. But people are using LLM as a judge. So you are taking another model and you are taking the outputs of your model and you're using one model to check another. And that commonly is using with like NLP models because you're using these language text models. But doing that locally means that you're not having any cloud dependencies that are required for the framework. And so your test suite, your metrics, your threshold are all running in your personal pipeline. Prompt Foo was just recently acquired by OpenAI. It's another lightweight evaluation framework. I use this one less, although I like it because it's a node framework, but you are able to use fast iteration. I like to keep my stack Python as much as possible. But you can, it's good for fast iteration testing, as well as scanning for jailbreaks or prompt injection or data leakage. I do want to call out Eval Coalition. This is really cool. One of my colleagues actually told me about this one. I didn't know about it until I was prepping for this presentation, but they are building this new evaluation card. So as I mentioned, model cards and data cards, now we have this semantic approach to documenting the evaluation of AI models rather than just the model or the data. So there's this also open data format, this public data set for AI evaluation results as well, called Every Eval Ever, which is interesting. Another deliverable from the eval correlation, excuse me, coalition. And then there are also do this, and I love approaches where it also brings in kind of community standards, and you have a framework and governance structure associated with it. So they have also this science of evaluation work stream, which some of this work comes out from, and they have this social technical assessment of approaches. And so it does meta-analysis, it focuses on open and reproducible scientific methods and governance and all of that. And so I really appreciate how they include red teaming and certification frameworks for some of these standards. And you may have heard today, I can say it officially, that Anaconda just acquired a company called Outer Bounds, and their workflow is based off of a tool called Metaflow. And so Metaflow is a tool that will auto version everything for a robust, reproducible pipeline, and leaves the advanced experimentation to the user. I'm also familiar with ZenML in my traditional stack. So that will track everything end to end, your artifacts, your runs, your metrics. And it also plays well with some of your dedicated tracking tools. So I would implore those who are like listening to do a little bit more digging on ZenML, but specifically Metaflow and Outer Bounds, which is really fun. And I've been actually, as leading up to PyCon US, I've been playing around with LangChain and Metaflow together because they're focused on these kind of step-by-step evaluations. And I think that's really intuitive on trying to cordon off and then figure out what the input, transformation, and output of each of your steps are. Let's see, is this the next one? Perfect. Yeah. So the integration layer, and this is getting through almost the crux of the full like presentation. Really, the heavy stuff is almost done. So, the integration layer is everything that will connect your sovereign model to the rest of the real world, another threat vector. So you have the APIs that your applications talk to, your access control that you govern, and it also includes that application layer for orchestration and tool calling. And you want all of that to be safe for your governance, your PII handling, your policies, your audit logs. So with that fully, and so I keep mentioning this maybe like fully local approach. I have another slide for that as well. But that allows for this kind of lockdown environment. And then you're able to route all traffic through perhaps cloud hosted observability platforms. And so you can selectively choose where your decision between local and hosted workflows. I like to call myself I'm a local first AI developer, and that also intersects with this kind of sovereign approach, but also with like my ethics, right? Like I have uh certain outputs or tasks that I don't want to run through AI because I think it's just not worth the compute. I think there are other more sustainable community focused ways to approach them. So I personally, and this is all personal approaches, but I do not use AI for my therapist. I do not use AI as image generation. And I like to reach out to my colleagues first for questions to kind of orient me into the right direction, and then maybe use AI or a local first approach before I start using cloud infrastructure technologies. I also like to care about where my data centers are, so I keep tapped into to those concepts as well. I also want to mention MCPs and gateways. Gateways have expanded, but are, as I mentioned, common practice in the AI, or excuse me, in the software stack, and they're being applied to the integration layer as well. So that has more features in the traditional AI stack for your cost governance or routing layers, and allows for you to build with the intention of long-term platform support. And then MCP, Model Context Protocol. I love a protocol. Similarly, has been taking wave through the ecosystem, but that, if you think about it together, they are both on this integration layer and are support for that gateway that you're working on. So controlling your tool access by your teams with granular permissions, or you're able to make sure that there's no data leakage through your tool calls or your PII. And also, you can invoke um, some of your artifact creations through some of these things because you're able to get some of these triggered responses. Another caveat, again, as I mentioned, like this local first approach, but you can be thoughtful of your observability layer and decide if and when a SaaS platform is what you want to do. Because what is the output of that of your observability calls? It could be sensitive data, perhaps. I mentioned a number of repos through this full stack, and I just wanted to kind of do this last slide to highlight some of the repos that I thought were interesting or that I mentioned. With a specific call out to Awesome AI Security Repo, which aggregates the DoD, CIO, NCSC, UK, SANS, BSI, and OWASP. I think I call it OWASP. I never really say it out loud, but OWASP guidance. And it does that all in one place. So specifically for this audience, I was really excited to find and surface that. I've not played around with it a lot, but I would love feedback to see if you hear about it being like an exhaustive source or a good source for your responsible AI toolkit. And the DoD AI Cybersecurity Risk Management Tailoring Guide is also another tool that came from 2025. Okay, so that was a large chunk. I went through all of the layers and I talked a lot about what the industry is doing right now to secure each of these layers of this intelligent application stack. One of the things that is personally near and dear to my heart is starting small and starting locally. So where can you in interject, or excuse me, start with your personal local experience? And if you're on social media, you may see that like everyone's running out to buy their own Mac Mini. You don't need a Mac Mini. There is like a lot of green on this slide that is between you and your Mac Mini. I want to highlight that. So across the top, there are the tools, like the common tools that tool levels that you can align to. It gets much more complicated when you want to support a full, if you want to, like, if I wanted to put a full matrix on GPU, CPU, OS, requirements, all of that, RAM requirements, all of that. But I kept it really simple with just having five across the top, one of which is the Mac M series. And then across the left side, I have different stages of the cycle. So data provenance, versioning, environment, fine-tuning, local inference, large language models, so like and using multi-users, evaluation, and then the last one on the bottom is going to be that gateway observability model signing process. And you'll see that six out of the eight controls require no special hardware at all. This is really geared towards um, uh, competitive consumer architecture and tools. Data provenance, model signing, SBOM generation, lock files, gateway setup, pipeline orchestration, all of that can run on the laptop typical people have in their room right now. The only layer that really genuinely requires hardware investment, in my recommendation, and please, this is like a feedback loop, so I really want to hear from the audience if you have opinions on this, are training at scale. So if you're using like serving 70 billion models to, or using it to multiple concurrent users, or those would really be some of like the bottlenecks. You can build in some of the processes that I've mentioned into the habits as you are building right now. I also want to talk about Apple Silicon. I am running on Apple Silicon right now. And so a 64 gigabyte Mac Studio can run 70 billion models at a 4-bit quantization. But for a researcher, for example, who does not have a server budget, that's the that's a capable sovereign inference hardware currently available right off the shelf, and is what I'm running on right now. But like I mentioned, the data stage, the model stage, the environment stage, the runtime stage, evaluation, and integration stage all have these different questions that we're approaching, and many of them can be answered on a consumer grade hardware. So, summary of a lot of what we talked about in concepts. We talked about provenance, which is the tracking in the origin and the history of the artifact in your pipeline. This could include data sets, models, weights, fine-tuning data, all of that. Without provenance, you're not able to answer the question, what was this model trained on maybe 6 months down the road? And these next few slides are really geared towards giving you your first step in approaching this. So the first step I would recommend is checking your data sets against the Data Provenance Explorer before using them, because over 70% of the popular fine-tuning data sets have incorrect or missing license metadata. Um, yeah. Oh, yep. So I went through the provenance section. Great. Um, Next, I talk about cryptographic signatures. Let's see, I think I messed up my slides on what assets are. Cool. Okay, no worries. Next is the cryptographic signatures. Just imagine that box on a one to the right. So signing model artifacts creates this verifiable record that I mentioned before, and the fact that it hasn't been modified or that it's from a trusted source. Or left that trusted source either. So you want it to stay where it's supposed to be and not have be tampered with. So the model card can make claims, but the signature really makes those verifiable claims checkable. And so if you're approaching this from the first time, I recommend installing the OpenSSF model signing CLI, and you can sign a model that you are already using locally. That the whole workflow to be able to start with the model signing CLI takes under 5 minutes, hopefully. Um, and I mentioned reference before the Atlas framework, which is a provenance framework. So Atlas collects these verifiable records for model artifacts from this end-to-end lineage for that full ML cycle. And signatures are how Atlas can make these provenance claims. And Atlas is just a really common tooling that people have been using lately. And so that kind of feeds into the next topic, which is the bill of materials, which is essentially a snapshot at a point in time. So the software bill of materials, and that's kind of colloquially been changed to the AI BOM as well. The AI bill of materials in this context extends that training data and model weights and evaluation artifacts. So you can audit at that snapshot what you have in your inventory. A common first check is using SIFT as SYFT as your first step. But if you are using Anaconda full ecosystem, that would be the proprietary tool. You can also get SBOMs and AI bombs. But by running that and SIFT is open source as well. You can like con install or pip install SIFT. But when you run that first step, you're able to have these complete shareable inventory of your stack. And hopefully, as again, that should be like under 5 minutes, under a minute. And that includes any CVs in any known packages. And the last one I want to talk about today is reproducible environments that I mentioned. So just funnel, bringing up to the top for my most accessible approaches. So reproducible environments, you can do that with any of your Conda or Pixie tooling. I know there's some things in the pip ecosystem. I have a whole talk about comparable why someone would pick the Conda ecosystem and comparable tooling. I love open source. I came from the pip and UV world as a full stack developer previous to my time here, kind of dabbling in data science and AI and ML. So there are definitely tools in that ecosystem as well to have reproducible environments. But specifically, I encourage you to think about pinning an exact version and cryptographic hashes so anyone is able to recreate your exact stack months or years later. And if you think about it in the process of like handing over an environment to another person and being able to reproduce that exact environment, it means that you have in like, kind of ranges for your pinning of your on your packages. For example, you can bring in dependencies and tooling that you did not expect to or have it named wrong. You can fat finger it. But there's a lot of opportunities for something nefarious to happen if you are not able to reproduce that environment later. So if you are locking it and then it is immediately starting up from a lock file, that is a really good step from your current environment today. And one command creates this immutable bit for bit reproducible snapshot of everything under your environment and your model. Okay. So that was a lot. That was like the majority of the that is the full presentation, right? So really the summary of today is encouraging you to do research, see how fast the industry is moving, look at all of the bodies and systems that are collaborating together to build sovereign, safe AI output, because building without these guardrails really does make this force multiplier technology, something that's making our current workflow much, much faster, um, a little bit off the rails, a little scary. And there are absolutely tools and people in the ecosystem who are thinking about how to make it sustainable, borrowing from practices that have existed in the ecosystem for the past, depending on what tooling, 30, 20, 10 years. And so I really like to see that how they're being applied. So deliberate ownership and sustainable autonomy is really where I'm encouraging the audience to play. And please, please, please give me feedback on the presentation. I would love to learn more about how you're using your tools or your fears in the ecosystem and continue that conversation. Thanks so much.
Amazing. Thank you, Don. That was a very insightful presentation. So thank you so much for all of your thoughts on that topic. I learned actually quite a lot from this about all of the different layers. It was incredible. Let's go ahead and jump into our Q&A and discussion. I'd like to also open this up to our host panelists. Do you have any questions for Don?
I have one. So GitHub recently announced they're changing their pricing on Copilot.
Yep.
I'm curious what your thoughts on how all of this stuff that seems like it is nice for reasons is now suddenly going to turn into a economic imperative for a lot of users and how that's gonna go.
100%. Okay, so I hope I'm answering the question, but my hot take that is a bit tangential to this and it's a bit of a hot take is I think that, and it is hot specifically because there's already these silicon bottlenecks of GPUs, right? And so people who are in the semiconductor space and the hardware space have been finding that, especially with the huge promises that are falling short with data centers across the world, that we are leaning into the hardware implications, and then everyone wants it for themselves, like consumer level, not consumer level hardware that could run some of these things. So kind of a yes and Tom, like I absolutely think that if people are interested in it and if it truly is going to get democratized, that we're all going to either need to scale back their models, reduce precision in our quantization, and think about more accessible and appropriate ways of using our AI. Um, our AI as we, approach what is intelligence, machine intelligence. And then my hot take part of it is that I think the next bottleneck after GPU is going to be batteries. I think it's going to be battery technology is so cool. It's also because I have a friend who's a battery chemist or whatever they call themselves, but it's really cool. And I
Mm.
think the portability and the efficacy of battery technology is just really going to like unlock this next evolution. So I'm thinking 40 years. I'm thinking 2035 instead of 2025. But thanks for the question. That was awesome.
And then James, did you also have a question as well?
I had a quick follow-up on Tom's question.
Sure.
How much do these things really cost? How much are they undercharging us? Is it the case in like 3 years we're going to be paying 100 times as much as we are for a token?
That's what they say. I had a question. So, oh my gosh, I love these questions. Yay. So I was in the hallway track coming back from lunch at Pi, Texas, and someone was like, "Why are all of these companies forcing their employees, because they work for themselves, forcing their employees to use all of the AI tooling?" And I don't know, I would love feedback, but my take on it was, yeah, I think they're undercharging us for this compute, right? Like they're not just, and I mean, we can get into sustainability and economics. Like for decades, we've been undercharged for the resources, especially in the United States, that we consume, right? So like we've never really had a fair valuation price for gas, for example, or for energy or our demands on our ecosystem. And there's a whole bunch of political reasons, political and economic reasons for that. And I think this, as I mentioned, the force multiplier of it all, I think AI is doing the exact same thing. And if I understood a multi-billion corp profit and loss statement a little bit more, I could probably tell you why. But I think there's a lot of interacting forces that are exactly what you said, James, like kind of shielding end users from using this true price in order to help with the proliferation of this technology, democratize this technology. And if we had that true value, I think the innovation would probably slow down. So where does that leave us? I don't know. Ask one of these CEOs. I'm just kind of sitting here with popcorn.
Oh yeah, sorry. I had this had raised a number of thoughts in my head, especially because I've been paying a lot of attention to the Mythos hack that happened recently.
Yes.
And yeah, I mean, I used to work for Engadget, so I was in tech journalism, and a lot of my friends now work at The Verge, and watching
Uh-huh.
them try to explain this to people in basic concepts. I think one of the dangerous implications of that and why Anthropic is trying to form Project Glasswing and all these things, security
Yep.
countermeasures, maybe even retroactively, is because they realize that in the same way that vibe coding has democratized um, coding as a concept, this will kind of democratize pen testing and of course, black hat activities as well.
Yes.
And I went to DEF CON last year. I saw a lot
Ooh,
of things that were sort of touching at the periphery of that. But I feel like we're about to face a situation where a lot of people that have very surface level knowledge of how these technologies work will start to use them and even use them offensively. Uh,
yes.
a really great book that I read just before I started working at Brookhaven was Sandworm, which talks about the sort of
I
stochastic
like that.
nature as to how the KGB operates their cybersecurity offensive, and that is, as I said before, totally stochastic. They'll go for literally any target. They're not like the CIA. They're not targeting specific people or
Hmm.
planting things. And I think that that will wind up being what we will see in the next couple of years as agents start to be the ones that run and coordinate attacks on things. So I guess my sort of question for you is how are organizations like Anaconda preparing for the average person to become a software developer who doesn't have a CS degree? How are you preparing to welcome them with open arms as they vibe code apps and, mutilate environments and do things
Yeah.
consider reprehensible, but they're normal people. They deserve to have participation in this venue.
So oh my gosh, I love this. So you like touched on a number of points. One, I wrote down sandworm. I'm not familiar with that one, so I'm gonna read that later. That sounds great. Um, Also, for people who are not familiar with Glasswing, it is a model that has maybe you can do a better job giving the description than I can, Carrie, but like it is a new model that is has the security vulnerabilities of the majority of the ecosystem, something like that, and then it has these very deep implications on if a regular person had access to all of that information, they would be able to penetrate some of the most secure systems in the world. And so they are allowing for trusted foundations at the top to have access to it. Did I miss something, Carrie, on that one?
No, I think that's a pretty much a perfect description.
Yeah, and so the to answer your question, which I think you could probably also do a better job of answering it too, but of answering that question too, but like from the outside of Anaconda perspective is one, I take that job on myself, right? I consider myself in developer relations an educator, and so where I learn, I try to teach. And this is a really interesting case for me. I really enjoy it. There is a survey that we recently published in partnership with the Python Software Foundation and a lot of maintainers in the ecosystem, called the Python Packaging Survey. And we got 25,000 results from that survey. And we had about 5 or 6 questions that all focused on security. And what are you looking at to personally validate whether or not something in your tool chain is good? And we had maybe about a dozen options, and people are usually picking the ones that are talking to your peers, visually looking at your repo, seeing what the most recent release is. But people are not doing things like looking at the full S bombs or deepening their knowledge of attestations and cryptographic signing, and they're like kind of aloof in concept. So I think is education. And so as I learn, I try to teach. And then there's building in some of these frameworks that people can use to model after. But even then, right, like if people are adopting the one model at scale, that almost makes the threat model just different. So you figure out the one or two things to get through that wide scale pattern, and now we're in a new problem. So I think it's like the nature of the beast also with things moving really, really fast, and people adopting similar pattern, and you're thinking about like now we're getting into sociology and behavior modification, and I don't know, also really cool, but like a whole discipline I'm not in. So answer is I'm not exactly sure.
Yeah, because literally all of this is the natural end of Conway's law. Like a system reflects the people who built the system. And
Yes.
when the nation state apparatus starts to play in this area, we're going to start to see a lot of that, especially with, the way that China has run their facial recognition systems.
Hmm.
A lot of people don't know this, but they're running, for the most part, in most places, a Gaussian algorithm that was developed, if I remember correctly, in Pittsburgh at Duquesne, and was actually sort of worked there because it was open source, and
Cool.
and now it issues fines to people who walk across the street at the wrong time.
Oh,
So,
wow.
it's crazy to think how far of an impact our open source work can
Hmm.
have, how far reaching all this stuff can go.
I also have this, so this is absolutely like not the Anaconda kind of spiel, but like Dawn as a human. I am really excited about licenses that are not specifically under the OSI definitions. And like I have super excited. So there's like usage ones, and I've done some work in the past couple years on ethical source licenses. So I'm excited for the conversation around the ecosystem to continue to build off of this license and have healthy arguments, as open source likes to do in public, about what should be considered and what's helpful and what can be tried in courts and things like that. But yeah, I 100% Carrie. It's just kind of like watch this space kind of thing. I don't know if I have a good answer.
Yeah, it's going to be a lot of reacting in the same way that,
Hmm.
when the Lodash attack happened to TypeScript like
Hmm.
10 years ago, that spawned this whole vendor ecosystem for Sneak to come in and say, we're going to
Mm,
monitor your supply chain in its entirety. So I think it's the same thing is happening now, just
yeah,
all over again.
cool. Yeah.
Absolutely. Well, that does take us to the end of the time that we had for today. I want to thank our audience for joining us today. And there was one topic that came up on reproducibility, and Don mentioned a tool, Pixie. And if you are interested in both reproducibility and Pixie, then you should make sure that you come by next month for our next Python Exchange, where we'll be joined by Ruben Arts from Pixie. But with that said, let's give Don Wages one final round of applause. Thank you all so much for your time and attending, and I hope to see you all next time. Thanks, everyone. Have a great rest of your day.